All right, so my name is Richard Hayes. I'm a CTI major. This will be my last semester if you don't know me. We're going to talk about the cluster in the back. I know it's pretty noisy, so if you can't hear, please move away from it. Hopefully I won't lose my voice. I'm a little bit under the weather. So the cluster is running OpenStack. We'll talk about the specifics of it a little bit. First, I'm going to go over kind of what OpenStack is, who uses it as far as industry standpoint, why do we care about it here. I am recording the presentation, so anybody that's a guest, if you have to leave and you want a copy of that, send me an email. My email address is up here. Or stop me in the hall and I'll send a copy of it. It'll probably take me about a week to do post-production on it. The PowerPoint presentation is pretty short, and after that, I'm going to run through some live demo. You guys hear in the back? A little bit? All right. All right, so the simple definition of OpenStack is it's actually a software suite, and it's used as a cloud platform. So you build public and private clouds with it. So most of the time in the industry, you're going to see this from a service provider or a large organization for an internal private cloud. Some of the stats on OpenStack, there's over 30,000 people that work on it, 20 million lines of code, definitely global, and over 350 countries, I think, or 538 companies support it. We're going to look at that in a little bit. So what can you do with OpenStack? Pretty much, I haven't seen any limitations on it. You can do anything with OpenStack that you can do on bare metal. So some of the big names are, you have infrastructure as a service, platform as a service, software as a service. Pretty much all heard those. Some of the more advanced configurations that providers can do, you can run firewall as a service, load balancers as a service, and that's VPN, both VPN connecting to a virtual network, so tunneling, and also a virtual private network. So you can do advanced network configurations, which we're going to look at that as well. So companies will run big data processing. You can run grid computing on it, and cloud-based apps. So that's similar to vApps. There's a couple modules in OpenStack, but I'm not going to cover too much because it's kind of outside the scope of what we would use it for here. But similar to VMware, if you're familiar with that, you can run Heat, which does infrastructure orchestration, and you can run Moreno, which is similar to a vApp deployment. So you can set up your infrastructure and apps and scale those up and down automatically. So who uses OpenStack? Some of the big names, CERN uses this for infrastructure as a service. They have 15,000 hypervisors, 150,000 VMs, and 44,000 researchers that are basically building up their own operating systems and running experiments all on top of a virtual environment. I think they have 200 gig link between two data centers, and they run something in the petabytes of data. So Harvard uses this for their research network. They do online higher ed with it, which basically what we would be looking at doing here. They use it for IT as a service because you can automate a large portion of your VM creation. And of course, you got MIT, PayPal uses it for e-commerce. They replaced 80,000 ESXi servers, which cost VMware about $1 billion, which is why you see the providers all have integration at the bottom. You got Best Buy, Comcast, Cigna, AT&T, a whole bunch of companies all use this for either private cloud or for their web-based infrastructure. So when you go to a lot of these companies' websites, the web server that they're hosting that on, or multiple web servers, distributed databases, are all running in OpenStack. They're all load balanced. All that runs on top of OpenStack. Providers, you have Rackspace, provides OpenStack clouds to whoever wants to use them. IBM, HP, and Dell all have public clouds that are OpenStack implementations, and VMware has what they call Bio, which is basically a vApp that runs OpenStack for you. So what can it do for us? So we can provide essentially highly available VMs that are data secure. So OpenStack runs, right now I'm running Ceph, which is a clustered storage. So it's similar to Gluster, if you've heard of that. It will replicate all the storage with whatever's loaded into it. So it's like RAID 1. You can accommodate current and future courses with very few limitations. We can run a lot of the server courses here where you need multiple VMs that all speak to each other. Run that there, access from in the classroom as well as from off campus. So it's flexible and scalability is far better than running workstations and independent servers for the BERT classes. The cluster back there, I added 3 more compute nodes to it, specifically for so you guys could run the KVM module for the BERT class. And it does provide infrastructure, so we can expand programs. If we get advanced courses working with databases, you can run distributed databases on it. We can do high traffic web servers, so you can look at load balanced web servers with a database backend. Those are all pretty advanced configurations. So the potentially affected courses, you can see pretty much every course that we run a VM in currently, you can run on top of OpenStack. So you don't have to worry about, I can only access it from this machine, or what happens if my portable hard drive fails, situations like that. So some more specifically, some of the problems that it solves is currently in most of our classes, we're running VMs in workstation, especially the server classes. So depending on what kind of flash drive you have, or if you have an external hard drive, of course, external storage is going to be slower. If you don't have access to external storage, or you're not storing your VMs there, they're on a specific computer. So all of that storage is going to be a single point of failure. If you're halfway through internet servers and you have your VMs on an external hard drive and your external hard drive fails, you don't have your VMs anymore. So OpenStack has a big solution for that. The 2 major problems are that I built the system for were data security and for access to the same VMs without having to use external storage for transport, so both in the classroom and outside of the classroom. This is kind of along the same lines, but classes with multiple VMs, more difficult to use on external storage. You need more resources to run them. Shortly, like Exchange server is going to be a minimum of 8 gigs of RAM now. The 2016 releases, pretty much all the Windows Server releases are doubling their minimum RAM requirements. The VMware releases, ESXi, is doubling its minimum RAM requirements. All above ESXi, all the vCloud releases and all that stuff are much bigger. We have a cloud and storage concepts class again. If we move higher into that, you can run System Center on this, run multiple System Center servers, run 4 to 6 VMs is what the normal configuration looks like in that lab. Our current workstations aren't going to support that. They don't have enough RAM. So that's resource availability will be insufficient soon. I have to double check with Nate on this because the new version of Overt does integrate with OpenStack actually, but our current Overt implementation, as far as I understand, the VMs on that don't really have access to each other. Overt has its own private network that it's running, but you get your VMs and you have access to those, and I don't believe there's communication between them. So OpenStack provides that. We're going to look at that. So access from in the campus, it was RDP and PuTTY, or off campus through Spice Console. I already mentioned storage is distributed and replicated, and it's VPN as in virtual private network per student. So we'll look at that too. There is AD integration from the management aspect, which some of the guests will care about. I looked up AD integration. It looks fairly simple. So the way that it works is OpenStack has an OU. Each project has an organizational unit within that, and then you dump users into those organizational units and give it access to the DC. That's pretty much the whole AD configuration. So it's relatively simple on that side. So the test implementation specifically here, I'm using Moranis's OpenStack deployment. So they have a business model similar to Red Hat. They're a top 3 contributor, so they do have quite a bit of extra modules that go along with OpenStack. We're running a ClearOS router. Is how VMs are getting back, so the ClearOS router is going to dump back out onto the sandbox. We have a Fuel master node, which is how the OpenStack environment is deployed. So with that, you can actually deploy multiple OpenStack environments, and it will pixie boot to a CentOS bootstrap, and then it uses Puppet, which we'll look at the topology in a second. Puppet's a scripting language or a scripting service for Linux, and it deploys all the configurations as you've done the settings in the GUI for that. So you've got 3 control nodes and 6 compute nodes, and then we have 4 storage roles. We don't have separate storage nodes on the cluster right here. 2 of those nodes are 2 of the controllers, and the other 2 are on compute. So does anybody have any questions? You can ask whatever you want.
Will this all make more sense when we do our lab thing? Okay.
Yeah, you'll have a lab document. So this is kind of just demoing your lab. It's actually really simple for you guys. So everything kind of happens in the background. So all you have to do is log into this dashboard. You guys already have accounts set up. So you'll log in. You'll see this. Come down here to images. Click launch. Give it a name. So here you're going to see in just a second, because of the way the current configuration is, that you're going to be able to see everybody's VM. What am I unable to do? So you click launch, and this is equivalent to creating a VM and workstation and installing CentOS. It takes, the last instance that I launched took 3 minutes. The first one took 7, so it does take a little bit of time, but it's basically a full OS installation. So you see over here on the right, we have this associate floating IP. So I'll click that. Click the plus button. There's only one public network, so it's going to automatically select for you. Let's see if it'll. It's probably not going to show me the addressing information until after it spawns. There we go. So to connect to it, use PuTTY or RDP. And this public address, the 10.238.253.47, that'll be in my portion of the lab document, is the difference between the 2 IPs. But that's how you physically connect to the instance. And then you've got the 192.168 address. That's the IP address that your VM sees. So whenever you're doing anything inside the VM with an IP address, like when you guys do migration, when you're migrating to someone else's VM, it's going to be that 192.168 address, because that's what they understand inside of OpenStack, how they communicate with each other. So from here, once that spawns, you got PuTTY or RDP or the console. So this is what the console looks like from the web interface.
Using OVNC?
Yeah, it's using OVNC. You can use Spice. I haven't set up Spice server on it yet, so we'll do that.
Spice does give a little bit better performance.
Yeah. I haven't set Spice up yet because from inside the building, you get far better performance just using a remote desktop connection or using a remote viewer or PuTTY. PuTTY's my favorite because you can cut and paste all your commands. It's nice. But so you can see this is kind of the access that if we had a production deployment of this is what you would see from outside of the building.
I was curious, would you ever use RDP and PuTTY outside the internal network?
No. Not unless we have a whole bunch of public IP addresses.
No.
Yes. Yep. From outside the school, you would have to use the web interface, which.
Spice Park, why?
No, there's a HTML5 version of Spice.
Okay.
So
that's cool.
Yeah, the only other option for like a PuTTY or RDP from outside the building would be an actual VPN into the network, or lots of public IP addresses. You would log into it through OpenStack. Like if you were at home, just what I did just a second ago. You would log into the same place that you go to create your images, and then instead of using like PuTTY or RDP, you actually click on the instance name, which normally you would just have yours. You would have your own. You wouldn't be able to see everybody else's. Oh, that one's still spawning.
Guys, you're not going to log in from home yet to work on these. This is still a work in progress.
OpenStack is all open source, 100% open source.
You listed a couple of other programs in there as well. Is it predominantly open source?
Are you asking about from the topology, the services from the topology, or Mirantis using Fuel?
Like all OpenStack, the programs, all the programs that you use were open source, so and this.
Yeah, everything that I use is open source. Yep.
Again, with open source being free, where do you get your support from?
Yourself.
Reading.
Yeah. Yeah. So one of the reasons that I use the Fuel deployment for OpenStack instead of building it from scratch is because Mirantis has that similar business model to Red Hat. So if we did a production deployment of this, we could get a support contract with Mirantis, and then if something terrible happened, they can log in and fix it. Which I'm pretty familiar now with all of the inner services that I just kind of glanced over, because we did have the power outage last semester, so I had to do a lot of repair to the cluster manually there. So it's not too bad. A lot of that, because it's designed for high availability and because it's used in very large data centers, most of that, pretty much all of it is redundant, and it's fairly resilient if you have simultaneous, like a catastrophic simultaneous failure. You can bring everything back up pretty easily. Yeah, this is why we don't like no VNC, because it times out. So use Spice. Do we have any other questions?
Anybody notice from the reading your documentation that where he was creating the bridge networks, exactly the same steps that y'all were looking at from the Red Hat Demo manual that I posted for you?
Yeah, everything I did inside the CentOS VM is straight from that Red Hat manual, or the Red Hat document for KVM.